Well, I'm going to combine two different questions together. So Eric Hansen on Facebook asks, I recently read that if all of the space were taken out of every human on Earth, the resulting mass would be about the size of a cube of sugar.
Yep.
How then can anyone adequately explain how the entire mass of the observable universe was once a point only microns wide? And then I'm going to combine this with this other question.
You're going to combine that?
That's a beautiful question on its own.
How are you going to add something to that?
Yeah.
Well, this is a little coda question. I could have thrown it out afterwards, but I thought I'm going to leave this just in your subconscious to bubble over while you're answering that one. From Ashton Norton, also on Facebook, other than the Big Bang, are there any other scientific theories that have been discussed as possible explanations for where we came from?
Well,
so those two together or separate, as you choose.
Okay, so this is basically a cosmology question.
Sure.
Right? So I'll take the cosmology question number 1. You can take cosmology question number 2.
I like both of them.
All right.
No, I'm just kidding.
I'll answer each one half.
Okay, you answer each half.
All right.
Leave me a little room at the end. Go.
All right. So the reason the universe is so different now than it was back then is simply because there was some kind of physics that happened between the moment of the Big Bang and the present day that we still don't yet understand. It is completely true that the universe back then, the density of the universe right around the moment of the Big Bang, at the Planck time we call it, was approximately 10 to the 97 kilograms per cubic meter. All right. And
that's pretty dense.
Yeah. And even if we took all of humanity... We're back in the 60s now. We went from the 70s to the 60s. We got to get some. Yeah, that's absolutely. You said it. We have a circumstance where the matter of that density is so removed from anything we can think of that human beings the size of a cube of sugar analogy, when you move all the space, that density is still only about 10 to the 15 kilograms per cubic meter.
So there was just another state of matter, or the matter itself was
Charles,
so different.
I thought it's not even that complicated. Okay. If it stays as solid matter, just taking out all the space between the particles, you're not going to get much smaller than that. But at the temperatures of the early universe, matter is not stable as solid matter. It's energy, and you can pack energy into any kind of small volume you want. So
that's the right way to say it.
Is that a fair way to?
It is a completely fair way to say it. And so as a result, the laws of physics that were governing that behavior produced something that eventually evolved into our universe today. And we have yet to decipher scientifically the processes that went from that to now. Wait,
I have to tighten that. It's not that it went from then to now. It went from then to a little bit after then. Because we know what happened a little bit after then until now.
That's fair.
That's good physics.
Yeah. And by little bit after, Neil, I think you're referring to 10 to the minus 30 seconds, right? Yeah. So 0.0000
a gazillionth of a second.
So we've managed to trace it back a very long way.
Yes. Right. But that last little bit,
that last gazillionth of a second is really hard to get. That's confusing bit.
And that segues into that second part of the question. It does. Where what is going on in that tiny, tiny fraction of a second that is so different from what we know today in our universe? And so that's where the speculation can lie, right? What could have happened other than a Big Bang as we understand it today? Could something else have generated the kinds of energies and effects that have led to the way the universe expands today? There's lots of speculation, but it's really, really hard to be able to decipher or to pinpoint the physics involved. We're adding extra dimensions, we're adding extra particles, we're adding all kinds of extra crazy ideas, and none of them have yet panned out in a scientifically verifiable way.
And let me just say, do you think we're happy about a Big Bang?
Yeah, that's a great point.
This is like weird stuff, all right? But evidence points to that.
Yeah.
The universe we now occupy can be described by what happens if you had a Big Bang as accounted for with a small, dense, hot, early beginning. And it gives us the amount of the hydrogen and helium and neutrinos and the age and the density and the distribution. All of this comes out of that. If you have a better idea, fine. We'll take it. But until then, we're stuck with the Big Bang. How's that? Is that another way to think about it?
I think that's a great point.
Okay.
Yeah. The imperfections of a scientific theory drive people nuts. Mm-hmm. We want theories to be perfect, but they're not. And that's where the science and the learning happens.
But what you don't know is whether the addition is just an add-on or whether you have to throw out everything and come up with a new idea.
Do you think that last gazillionth of a second will be explained or is it even explainable?
We've got top people working on it right now. Mm-hmm. They're called string theorists.
Yeah.
Top people.
And cosmologists in general. Yeah.
Top people.
Mm-hmm. String theorists is just one group of promising paths. But all of cosmology is really about trying to get that last little tiny bit.